entitled the Perma Pure PD Dryer's Introduction and Performance, and it's going to cover our entire line of Perma Pure PD gas sample dryers with Nafion. To start, let's just review what is Nafion and what makes it so unique. So Nafion is a copolymer of Teflon and sulfonic acid and is highly resistant to chemical attack. Nafion removes water by a first-order kinetic reaction, so equilibrium is reached very quickly, typically within milliseconds, and the transfer of moisture is driven by the differential water vapor pressure between the membrane sides. Nafion permeation selectivity is based upon the chemical reactivity, not the size of the molecule. It's not traditional permeation. So there on the right, you can see that diagram of a sample gas stream moving through the Nafion tubing. The yellow, red, and green jelly beans represent the chemicals being analyzed or wanting to be retained in the sample, and the blue represents the water being removed from that gas stream in the vapor phase. So the way we like to look at it is to take an example of like a bug screen. Bug screen has holes in it where only certain parts or certain molecules can move through the holes in that screen. Well, that's traditional permeation. That's not what Nafion is. With Nafion, the water actually becomes a part of the material's chemical structure, and that water moves through the lattice of the material and goes through one side of the material to the other. Only compounds that are chemically associated with sulfonic acid will permeate through Nafion. Because this is a specific chemical reaction with water, the process is very selective, and most gases being dried are entirely unaffected. And this is particularly what makes Nafion so valuable for the scientific and technical community, because the type of gases and compounds and elements that we're looking to measure are held intact, kept intact by Nafion. So let's go to the PD dryer series. There's an image of different PD dryers of different materials. And basically, the basic design is similar to our MD. MD means monotube and PD means polytube dryer. Basically, the dryer is a simple tube and shell design that functions with water vapor, similar to how a heat exchanger transfers heat. There you can see in that diagram to the right, the wet gas comes and enters the dryer through the top and exits to the bottom dry. And there we have a counterflowing purge gas stream that exits at the bottom and that enters at the bottom and exits at the top wet. The PD has multiple tubes in parallel to increase the flow rate capability and efficiency. Dryers are corrosion resistant and rugged, making them long-lasting and tolerant of very harsh samples, perfect for the type of applications that most customers use them for. No routine maintenance is required. They're reliable and easy to operate, and they're also the most common dryer used with SEMS or continuous emissions monitoring systems. Some of the features of the product line, we have flow rates. You can dry sample gases with flow rates up to 40 liters per minute. We have operating temperatures with a maximum of 120 degrees C. And there, the maximum operating temperature is dependent on the materials that are specified. The simplest material, of the polypropylene materials, those are good to 80 degrees C. The fluorocarbon versions are good to 90 degrees C, and the stainless steel versions up to 120 degrees C. We also select these materials based on the corrosion resistance requirement that is put from the sample gas composition. Operating pressures to 100 psi. They're available in straight or flexible configuration. We have versions with a rubber shell that allow you to move the dryer around to fit into your equipment or to some other configuration. Standard dew points to minus 25 degrees C with minus 60 degrees possible in special cases. There are no moving parts, and the dryer continuously regenerates. That means the moisture transfer is an intrinsic property of the membrane itself. Let's look at the PD series performance curves. On the y-axis, we have the dew point that is achieved by the dryer, and on the x-axis is the flow rate. So you take a look at the type of dew point that you want to get. Let's say you want to get to -10, and you have a flow rate of 4 liters per minute. You can look on that graph. That gets you a 24-inch dryer in a PD 50T size. Now I want to make the point that all of our performance curves have been generated using saturated ambient air at ambient temperature of 20 degrees C and a purge gas of 2 times the flow rate of the sample gas using instrument air dried to -40 degrees C. We do have other variables that could change which dryers you want to use, and those variables are pointed out in another presentation called Best Practices Choosing a Nafion Gas Sample Dryer for Your Application. So you can select that presentation and read or listen to a little bit more about that there. Let's look at the intelligent product numbering system of the PD series. Here, the first part, obviously PD is the series. The second part is the tubing in terms of the amount or number of tubes. There 50T or is 50 0.030 Nafion tubes in parallel. That's 30 thousandths OD. That is a very small diameter tube. We found that that has a very high drying efficiency, so we can pack a lot of those tubes in the shell. We have that in 50, 100, or 200 tubes. We also offer PDs with 18,070 tubes or 60,060 tubes, and those numbers there are a little bit larger, 070 18T or 060 60T. Those two versions were specifically developed for particulate drying. The third call out there is the length. They are available in 12, 24, 48, and 72-inch lengths. And the housing material, we have quite a huge range of housing materials. We have in the part number MPP. M means molded. Those are molded ends. And PP is the material of both the end shell and the end connections. So there we have MPS, molded PP fittings with a stainless steel shell. There's MPR, which is molded polypropylene fittings with a rubber shell. We have others there with molded PVDF fittings with either anodized aluminum, stainless steel, rubber, or corrugated shells. The rubber or corrugated shells are the ones that are flexible. We also have full machined stainless steel end fittings that are available with either an anodized aluminum, stainless steel, rubber, or corrugated shell. And we also have part numbers there that call out dryer element replacements. And there, if you have the courage to replace the PD element, we also recommend our PD removal tool, which our customer service team can quote you when you call in for a price for the element. Here's a graph that shows you how to calculate the PD series pressure drop. There we have a simple calculation of the pressure drop in PSI is 0.0056 times the flow rate times the length of the dryer, and those change depending on the number of tubes. So in general, the customer experience, having made these PDs for over 30 years, they've been proven to be rugged, corrosion resistant, continuous and self-regenerating, reliable and long-lasting, with proven and predictable performance. That means the dryer you buy today is going to perform the same as the one that you bought 10 years ago. They are cost-effective and maintenance-free. And some typical drying applications for PDs include sample gas conditioning to remove water, for the protection of equipment, for higher accuracy, and to retain water-soluble compounds, and they're used in continuous stream or batch water removal. We also use these in our own sample gas conditioning systems for continuous emissions monitoring systems. Most of them do require a high flow, so these dryers are typically used with flow rates of 5 to 20 liters a minute. They're also used in aerosol particle analysis. We maintain relative humidity for consistent measurements during the daily RH cycle. We replace the desiccant column as the primary application. These are typically used for flow rates over 1 liter a minute. We have a lot of customers using them in 5 or 10 liters a minute flow rates. And there we also recommend our special constructions using 060 and 070 tubing to minimize particle losses. And to finish out the presentation, I want to point out that in order for us to help you select the right dryer for your application, we have what's called the Perma Pure 10 questions that basically show you all the information we need to know and its context to be able to pick the right dryer for you. When you call into our customer service team or you want to reach me directly with an application, please provide all of this information. This will help us pick a dryer that is best for your application.